So luckily I do have some familiarity with particle filters. I mean, I haven't implemented it in 20 years, but I did implement it once. It was one of my actually a paper I really liked, the Thrun paper from 2001, the mixture MCL was like, I was really pleased to just see it by chance in the Thousand Brains project paper, that it was a fun connection.
Yeah,
Yeah, then there's always the details of like how do you actually use the sensor data to update the observation. And I think
yeah,
one place that I was getting stuck was um, trying to apply the sensor data to all the observations or to all the hypotheses at once. I think that's what I was trying to do it like in one fell swoop, rather than it's like, oh yeah, if you're just looking at one hypothesis at a time, it's sort of almost trivial to update that hypothesis with the off object, yeah, observation.
yeah. So I guess it's kind of like, yeah, basically they'll all be kind of integrating movement, and so they'll all think they're, somewhere in that object's reference frame. And then they're just going to get that sensor data. So if a hypothesis is being updated, it's going to get the sensory data, which may or may not match what was learned at nearby points. And so once a hypothesis moves through space, in this kind of reference frame, and then it's receiving sensory data, and it's basically going to look at its kind of learned neighbors, to see, does anyone kind of match what I'm getting. But if it's nowhere near anyone, then that's kind of this out of model situation where it's like the point has moved like super far away. And then if it's kind of the more kind of strictly just off object, that I guess implies that, okay, it's moved, there's some learned points nearby, but it's getting this observation that's like saying, oh, I'm sensing nothing. And that's where we kind of want this high prediction error. But I guess like in some ways it's good, in some ways maybe you could say it's computationally expensive, but like as long as a hypothesis is considered kind of good enough to continue updating, we're going to move it with the incoming kind of movement data, and then pass that sensory information. So we don't need to kind of work out, I guess, like what is the correspondence between the hypotheses that are being updated and something like kind of array of vision or anything like that, if that helps. So it's yeah.
Yeah, I think when you move the sensor on a single hypothesis, like a single model,
Yeah.
right? Move, and let's talk about distance sensors, because I think a touch
Yeah.
sensor is like even more trivial, right? So like a distance sensor, you move it, and obviously the depth of the model is different in different places. So like moving
Right.
the eye, right? That's the process where it's like, oh, you have to find where it lands on the model.
Yes.
So
Yes,
that's
you're
the
right.
ray that I had in my head.
But
The ray is deciding where the sensor is landing on the model.
so what we
So
do right now is we have the depth information, which together with the location of the sensor, we have the location that's being sensed.
Oh, but I'm
And
talking about
so
just in the model,
so
not
without recognizing the model, we have a location, a new location, and then we have the previous location, and then that's kind of that displacement in the world space.
So yeah, basically the whole taking account depth already happens in the sensor module. So, or actually already in the transform before it gets to the sensor module. So I think maybe it's useful if we use and just a whiteboard for some of the
Oh, that's
things.
a good idea.
Do you mind if I make this off object out of model one public?
No, yeah, please.
Okay. Okay, I'll just post this link in the Zoom channel.
Okay, right. So you're not predicting where the sensor would land on the model. You're looking at where the sensor actually landed and then figuring out the transition between those 2 points. Okay.
Yeah, so it kind of assumes that there's depth information, and then of course it benefits from at the moment that all the kind of path integration. So that's both like accounting for how much the sensor moved, and also what is the new depth estimate. Obviously the more noiseless that is, the better. But basically that's going to just give us a new location, and then that we're sensing at, like that's basically, that's like the location of the feature that's being sensed. And so, but in that sense, it's not that different kind of from the finger, because it's like whether we're physically touching it or we're seeing it at a distance, the kind of location of the feature is out there in the world. It's kind of, it's not, I don't know, in the retina space or something like that. It's kind
Okay.
of, and
So
then that
can I
means,
ask,
yeah. Oh yeah. Well, I was gonna say, and then yeah. So if we have an old observation like that, and then a new one, then we can do that, calculate that kind of displacement in world space, or it could be, you know, ecocentric space relative to the robot or something. But anyways, we have that kind of displacement, and then the learning module has a hypothesis about the orientation of the object, and then it can use that to transform that displacement based on different hypotheses. And so different hypotheses are going to move in different ways on the object based on different hypotheses about how the object's actually oriented.
okay.
Um,
So this is a question to make sure I'm understanding what you're saying.
yeah,
Which is, so if I have a model of these glasses,
yeah,
and I move my distance sensor to the side here,
yeah,
and let's say there are two different models, one with only one of these and one with both. So I look at the glasses at the side here, and
yeah,
one of them is missing or is folded or whatever, and
yeah,
so my distance sensor lands on the further of the two.
yeah,
So that is what gets sent into the hypotheses, and that's actually going to end up matching both models, the one with and without the hook that's closer to me. So
right.
even though
Yeah, yeah.
even though my mental model of the glasses would tell me that the one with the hook closer to me should actually,
There should be like
there should be
something
negative
obscuring your
evidence
vision,
on
kind of.
that one.
Yeah,
Yeah. So the fact that we're using where the sensor actually lands and then just moving to there in the model ignores the fact that there's an obscuring feature in front of it in the other model.
yeah,
Okay. Okay. So but that's how it works right now. That's
yeah.
fine. I just want to make sure I understand how it
No,
works.
no, that is a good it's a good example to kind of, yeah, exactly. So yeah, basically there's no way of kind of accounting for this kind of ray of vision, and that's kind of come up. I don't think we've really discussed it in this kind of exact setting like you described, but it's kind of come up in terms of like, say you want to test a point now. So like you may have seen, we have like a policy that kind of suggests, oh, I should move to the handle, things like that.
Mm-hmm.
But we've kind of thought, okay, depending on where we are on the object, you would have to move in different ways in order to actually see it. Like sometimes there might be some self-occlusion, and sometimes there might not be. And where is that kind of knowledge stored that, okay,
Mm-hmm.
and yeah, it could be maybe anything from more like a scene level representation that's kind of accounting for both like models over about your sensors, like maybe you have kind of models of how your eyes work and how they kind of sense and understand this kind of concept of self-occlusion, or yeah, things like that. But because I guess we don't want to wrap up, it might be too much to try and wrap that up into kind of a single learning module, that it kind of, that for some reason like a distant learning module has this sense of like, if I view from certain directions, it'll be obscured. But anyway, so we don't have, I guess is the short answer, a way of dealing with that. But yeah.
I mean, the main thing is that the cortical messaging protocol, so whatever a learning module expects, is basically just a 3D location and orientation in space of where the sensor is sensing. And so it doesn't expect where the agent is that the sensor is attached to, but it expects the location of where the sensor is sensing. So, for example, I think in monkeys, there are these, what's it called, spatial view cells. Right? They basically fire whenever the monkey looks at a specific location in the room. And it doesn't matter from where the monkey is in the room, or like where the eyes are in the sockets or anything. It just matters where in the room, what location in the room the monkey is looking at. And that's kind of what we expect as the input for the learning modules. Kind of try to make a very brief diagram of what kind of info is available at what point. So basically we have the environment where we have the entire object, and then we have the sensor, so a little camera patch, for example, that sees a small part of the environment. And so in most of our experiments, we basically get an RGBD camera image and a location of the sensor. So that's the sensor location is actually the thing of like the camera that's up here and looking at this location. So that would be the location of this here, plus the RGBD image. And then we apply a transform, and the plan is to eventually wrap this transform into the sensor module actually, but this is how it looks right now. So basically the transform takes this depth image and the sensor's location and combines the two to basically calculate an array of 3D locations, basically saying where in space is each pixel. So basically adding the depth values together with the sensor location. So then we have like an array of each pixel where it is like basically hitting the object in space. And that gets sent to the sensor module, and then the sensor module turns it into a cortical messaging protocol, which is, it basically takes the location that's stored at the center pixel of the patch, and then it uses the rest of the pixel locations to calculate the surface normal and curvature directions to define the kind of orientation in space. And then it takes like the color at the center pixel too, and some features.
Right. And so to maybe kind of rephrase what you were saying earlier, Vivian, and kind of relevant to the glasses example, is like if the learning module is sensing this mug and it senses this inside wall, it doesn't know if it's up here and that's why it's sensing it, or that it's kind of here and there's like a hole in it and that's why it's sensing it. Like it just kind of knows, okay, I'm getting a something at this location. And yeah. And at least I think our intuition right now is that would almost be like another learning module's job, is to kind of learn this idea of kind of occlusion and what that means for particular sensors. But yeah, I think it's an interesting question though.
Yeah, I mean, I guess it's similar to having a different object occlude yours and keeping in your mind that there is another object behind it. Like, you
Right.
know, yeah.
Yeah, it's like it's not something we would represent in the input level. But at the like you might have a higher level learning module that has like a scene representation of that there's something behind it, because it has seen it previously at that location. And then yeah, like Niels mentioned, maybe at the output level, when you calculate an action, you might use that kind of scene model to calculate that you need to go around or something like that. But at the input level, it doesn't really matter.
Yeah, I guess it could even help build intuition about like where the hierarchy should break down. Like if something can include another thing, then maybe it should actually be sort of different sub-objects that are built together. Well, I don't,
Right.
I shouldn't do too much speculation because I have no idea
Yeah,
what
yeah,
I'm talking about. Oh, okay. And there was one kind of maybe tangent. I couldn't find, I think it was Niels that you said something about this problem is kind of solved already in a multi-object scene. Like if you go on to a different
Yes.
object and come back. So I didn't, I guess my first thought in response to that is, like if we just treat off object as like, you know, a distant wall or something, which I think you've also brought up, does that mean everything's already solved if we just actually like if we just feed in a distant wall with, say, like a surface normal pointing at us, and you know, like Like, does
Yeah,
that mean this is already solved and we don't have to do anything special here? You know, I guess that's always a question to ask at the beginning is
right.
like, are we doing a
I mean,
special case for something that doesn't need a special case?
yeah, I guess it's just like, for example, with the surface agent, then it may be relatively close to the object and it's kind of sensing nothing. So it's not always, because it part of that kind of already working relies on the fact that it's like it's really far away. And but then I guess the other thing is just yeah, it kind of fits with the feeling that okay, yeah, there are no morphological features. Like when I look at, at least I don't get a sense of a surface when I look at the sky. Maybe there's something, or in a kind of black well. But and certainly when my fingers just like hovering in space, I don't have a sense that there's like a surface there. But I think it points to that
Sorry,
at a
yeah.
certain level, the change is relatively small. That we just need this kind of special like, oh, it's none for morphological features, and then a lot of the kind of stuff that's already there in terms of like feature matching and updating the location and stuff like that. Like, yeah, updating the location. It's like, oh, okay, I sense nothing at a distance. Like now my sensor has moved super far. Okay, now I'm way out of reference frame. Right now, that's going to get negative evidence and things like that. So I think we do still need to change it, but I think it points to that. It's at that level, it's not that big a change. It's more just that it has all these kind of knock-on effects. Yeah.
Right. Okay. Yeah.
But yeah. But no, yeah, these are great questions. I think you definitely understood the problem well. So
there were maybe some slight differences. Well, I guess I wanted to go over the sort of the high level plan. This is almost more of like a process project engineering view of it, of like what are the steps that we do, and so Viviane did that first summary of like sending the observations to the learning module even when you're off object, and then step 2, sort of in the learning module, process the empty observation whether you're in or out of model. So like I wrote that down in my notes as like phase 1 and phase 2 A and B. And I think actually that sort of step 1 of sending the observation to the learning module, if you then cut it off at the learning module, then you can sort of make all the changes in a refactor that shouldn't actually change anything, right?
right.
So yeah, that's like sometimes a nice element of or feature of a big change is like nothing should actually change in the output behavior.
Right.
So I was imagining that for that phase 1, and then phase 2, and this maybe goes a little bit different than how you wrote it up, Niels, I was thinking of doing the out of model movement where you so basically ignore in model movements and just do the out of model movement where you do that job of keeping the hypothesis around for at least for a few steps. Which again, I think should basically not affect the behavior from how it was before. Like
that one will, I think, just because right now that gives right now there's negative evidence kind of right away as soon as you move out of model.
right,
so if you
okay.
And that's why we think it might. I think there was kind of a comment that it might slow down inference a little, or like convergence a little, because right now we kind of if you're far from any learned points, you immediately get I think it's actually the maximum negative evidence, like -1 on that step. Whereas here there basically be this delay. So that one it could still be done as a refactor in that you probably have a hyperparameter, which is like how many steps before it becomes kind of detracting, and if you basically set that to like 0 or 1 or whatever, then it should give the same effect. would be kind of one way to sort of do it as a sort of refactor.
And this shouldn't change anything if you go out of model, but the real observation is still on an object, right? That's still the same. We're only dealing with the case where both are true. You've gone out of model and out of object.
So as in, it will change performance. So out of model is in some sense, yeah, this is why it's kind of complex. Out of model is in some sense orthogonal to off object, in that
Right.
it can be out of model whether it's off object or not. And in both cases, we would want to clamp the evidence. So whether it's gone off and it's looking at a distant object, or it's gone off and it's looking at a void, we still want to clamp it for those few steps just to give it a chance to kind of move back.
But if you go off model but are on something at the same distance as you were before, then you should still do the negative evidence, right?
No, because no, not if you think you're off model. Like if off model, I guess is basically saying like, okay, we can't say anything because we don't for that particular model, we can't predict anything.
Okay.
And so whether it's whether we're sensing kind of something real or because and it's also kind of I guess from a practical point of view, like that example of like the eye and the vertical line or the 7 and the 1. I don't know if that was helpful, but like there could be, different things that we sense when we kind of move to that space where we're expecting something. And often it won't be off object. So like often there will be something there. I guess
so
it is.
The one model should not get negative evidence when you move to the 7 bar.
Yeah, for those brief well, yeah, that's correct. And even if it was a 7.
Why wouldn't it?
So the real thing you're looking at is a 7, you have a model of a 1, and you move to the bar at the top of the 7. Obviously the 7 will improve.
Yeah.
You're saying the 1 should just be on ice.
Clamped briefly, yeah. And then it'll start getting negative evidence.
Okay.
I
think we have to do it that way.
Okay. Yeah, because the one just doesn't. Yeah, the one just doesn't have a prediction about that location.
Yeah, but yeah, basically, I don't think we want the intersection of off object and out of model to be like an even more special condition. Because it sort of relates to this whole thing of like, do you store that there's nothing there? Like, how do you know whether to predict off object or something else? Like, are we meant to be storing that, everything else is off object, but it's like, it might not be. There might just be something. So I think that will work if we just, if we do it like that. But it just means that, it's just the things like inference might be a little slower at first because of the kind of putting, as you say, everything on ice for a couple steps.
Okay. And so, I just had a look again at the code for the sending, like concretely sending the off-object observations to the learning module. And so what we currently have is, so if we're not on the object, morphological features will be set to an empty list. And when we construct this kind of state instance, that's the output of the sensor module, we basically have morphological features be an empty list. This might actually have this. Well, okay.
Might already be enough. Yeah.
I'm just looking if features will be in there. I think there might just be this object coverage feature in there because that's part of this if branch. So I think it wouldn't actually include color right now. Not sure if we want to add that. But then use state will be set to false because on object is false. and also invalid signals is set to true. And so the sensor module outputs this state, which, yeah, it will have a location, an empty list for morphological features, which is what we want. But then Monty, the kind of the class that wraps around sensor modules and learning modules and kind of routes the information, when it routes the information from the sensor modules to the learning modules, it looks at this use state flag, and if it's false, then it won't add this to the learning module inputs. So I think this will be the first point of change to basically remove this if statement. And then that should make those to be sent to the learning modules, although this will also make other things be sent to the learning modules that we still don't want to send there. So
what about that bit where we set the flag?
Yeah, we could also just set use state to true in that. We could just remove this part here. I think that might be better.
Yeah, and also the invalid signals, what does that cover otherwise?
Sometimes
Got multiple things.
Issues with extracting the surface normal.
Yeah.
And the feature changes them, I think, also sets use state to false if there wasn't a significant change in features.
Yeah, that one is fine. So we don't want to interfere with that one, the feature change sensor module. I'm just wondering whether we could kind of unify, like, if the signal is so corrupt that you can't really process morphological features, maybe it's worth just treating that as off object or like this kind of null observation as well.
Yeah, I guess.
Do we still get that?
I don't know when would that happen? Like, what's the? I guess is it because there's just like a weird distribution of depth data in a single sensor patch?
Yeah, I think it's really special cases, and I'm not sure we would want to treat it as off object, because I think it happens very rarely, but if I remember it right, it's something like if you look at the surface dead on or something, and then the matrix, there's some division of 0 or something like that.
Okay.
I think can happen both with surface normals and principal curvature.
Yeah. Okay, so then I guess we just want to make sure that is invalid is not true. In the case of off object.
And actually in the very ugly, not invalid. Maybe something like this.
Because are we with this the logic above the if else and stuff? Did you say morphological features is being set as that empty dictionary if we are off object?
Yeah. So that's
okay. Yeah. If on object, right?
Yeah.
But so valid signals. Okay, but isn't this where the check happens for valid signals? So we maybe don't want to change that. Or like it feels like we need to catch that separately, something like that. But we can maybe just make a note of this. We don't necessarily need to figure it out right now. But I'll just write.
Wait, what? I think
I'm just saying. I guess we want to catch true invalid signals, which is the thing you were talking about, like the kind of weird depth data. Yeah. But then we don't want to set is invalid for if it's just off object. But so I feel like we need like an additional if or something like that.
Yeah. Right. We'd probably not just want to set this to false whenever on object is false. So
yeah.
We just want to set that to false if object cover.
I think we actually want it true there, right? We want it if we're off object, it's a valid signal with just empty morphological.
I think I'm making it a bit confusing now because I renamed it to valid signals. This one will return true.
There's also a lot of double negatives, not invalid,
Yeah, that's why I changed it. But if we rename that now, then we
Right.
have to rename it everywhere in this function and invert what it returns. So let's
Right.
not make it more confusing for
Um,
now. But yeah, basically what we want to do is, well, if this thing is true, then invalid signal is true. And then if on object, we do this, otherwise we set morphological features to an empty list, but invalid signals is still false. And in that case, use state would only be false if they're actually invalid signals.
yeah, that looks right.
Then, I mean, there's another, it could also be done within this function, the onObject check. And then that way we could still return color, for example, like we could still return non-morphological features.
Yeah, maybe that's like a nice to have, but
Yeah, more of a nice.
um,
But yeah, there won't be as many anyways, like we won't have curvature magnitude and stuff like that if we're off object. So
yeah,
I think it's not that important for now.
right.
But the important thing is we'll still get XYZ locations, and we can then, like, what if we set this flag to true, it will automatically be routed to the learning modules here. And then I'm not sure, this is so long ago, but it looks like we already have a lot of code in the buffer to deal with incoming on object or off object observations. So we already kind of store the on object value, which right now should only be ones or only be truths. But if I don't know, the optimistic view would be that changing this, the buffer will already deal with getting those and will, oh, wrong file, and will already store for each step whether we were on or off the object. And then
Yeah,
it already kind of like the, oh, okay, this might have to be changed. I'm not sure if it filters by on object. Uh, when it
yeah,
goes to
that's one of
model.
the, I think the tricky things is all this
Yeah, so it already has functions like get all locations on object, where it takes all the locations and it filters it by whether we were on the object or not.
yeah.
Which kind of confuses me why we wrote all this if we're not already getting.
I'm trying to remember if this stuff predates, if there was a point at which we did pass off object observations, and then we found that that was causing an issue.
Hmm.
Or is it because does this buffer also store sensor module? So like if this buffer is, yeah, it doesn't, right? It should
No, it
just be,
shouldn't.
it's a bit mysterious.
Yeah. Well, something to
Um,
uncover.
yeah, but yeah, like you say, maybe it will already handle some of it, but because
Maybe
yeah,
it will
I think
already work.
at its core, some of that was presumably written for like filtering logging so that we could be like, okay, we're just going to observe what hypotheses changes happen when we were on object and stuff like that. But as you say, Vivian, generally we've never been or in our memory, we've never been passing off object observations. So that's always a list of ones or truths of the length of steps, basically.
The buffer doesn't include things like when you're moving the surface to the sensor to the object, like because there's sometimes there are
Yeah, like at the
steps where you're
start.
not doing any inference, right?
Right.
Yeah.
It might be that it includes, even if it doesn't include sensor module stuff, it may include basically every time. I think that's what it maybe is, that like every time the learning module could be stepped, including when it's off object.
Hmm. Yeah, maybe a good place to start debugging and testing would actually be this unit test here called test moving off object and back. Because that runs pretty fast. You don't have to run an experiment or anything. And it like uses just fake data to move beyond object and off and back on, and just kind of seeing what happens.
Yeah, that's great.
Uh, and yeah, it won't cover if you make changes to what the sensor module outputs, because here we are not using a sensor module, we're just manually creating some fake messages and setting morphological features to on object to 0 and use state to false. But it might give some insights on what the learning module does with that. Oh, well, actually, yeah, maybe it's not the best place, because this doesn't even invoke the Monty class, so it doesn't include any filtering. So this one, we're just directly stepping the learning module and actually giving it the information. Uh, so maybe
Oh,
well, it might still be a good test for very specific changes, but it wouldn't test the kind of end-to-end pipeline of how Monty passes the observations between sensor and learning modules. Let's see.
what was the one where we stepped through the learning modules? That kind of and past the sensory. I don't think it's in Monty base.
Oh yeah, here in evidence LM test we have one, I think, where we actually do a full experiment. So yeah, test moving off objects is the name of the test. And I think the way we do it there is that we run a full experiment, but we pre-define the actions that will be taken so that the actions just take us straight off of the object. Um, yeah. Yeah, this is probably the best test to start with. Sorry, it's been a bit of a while since I looked into that. Uh,
No, this is great. I mean,
Yeah.
this is still way faster than if I was just, swimming around trying to guess at it. So this is great. I also, just as prep for this meeting, I did some like poking around and found some unexpected behavior, which is perfect because I get to ask about it now. Um,
yeah,
so I did what's the easiest way? I mean, I guess I could share my screen. But I did a change on handle failed jump where I just delayed the fail step. I switched it to just always treat it as successful, and
Hmm.
then added this like queued action that happens at the beginning of that same function uh to like reorient it. The idea being like, oh, it'll reorient it at the beginning of the next step.
Yeah, so
Um
you can get that off object observation and then
yeah, yeah.
move back. Okay.
Yeah, so here, maybe I can
Yeah, unfortunately that
will this work?
whole policy is a bit of a mess.
so I just added this like concept of a queued action at the beginning, and I mean, this isn't how the actual change would go. This was just me trying to understand.
No, I think it's it's a nice way to test it. Yeah.
And so the surprise effect for me was so I got the log that says, there's no object visible. And then the next log is supposed to be the one saying, okay, I'm now moving to the object, but instead it was showing up with like a huge gap. So it would say like, warning, no object visible in step 7. And then somewhere down in step
after a bunch of steps.
13, then it was like returning to the previous position. So okay. I don't understand something about like when this code is triggered, basically.
What that probably is the motor stuff is really complex and a bit of a mess. But basically there's different logic for handling off object from a motor system point of view. To kind of summarize them, I guess, the distant agent tends to, when it's like saccading around, in most versions, if it goes off the object, then it moves back on. It reverses the last action. But that should be on the next loop, and so it should give it a chance to kind of pass the observation. And then, like you noted, the jump to goal state fail, that happens all within the kind of environment, embodied environment, and so it doesn't give a chance to pass. So which is why I guess you were making that change. But then there's also, for the surface agent, if it's off object, it will kind of try and look for the object. And in particular, the finger, you can kind of imagine it sort of like shifts around until it tries to kind of like bump into the object. So what might be happening is that logic is getting that's catching earlier than your, so you might, for the purpose of this kind of test, you might need to move that even earlier. So I think it's something like if the observation is none or something like that, there's some sort of if statement really early on. And then I think that will trigger, it's called something like
this is the environment interface does the execute jump attempt pretty early. I don't think the first step isn't triggering, right? So this is pretty much right away. And then this queued action's like right at the beginning of that. So I don't see, I mean, unless this moves into like a different class somewhere, I don't see how it could make it happen any earlier. I don't understand how to make it happen any earlier.
Right.
It might generally be easier to debug with the distant agent, because that one kind of more frequently just moves off the object and then we just revert its action. I think with the surface agent, it's a bit more difficult because whenever it's off the object, it's usually that something went wrong, like it kind of fell off or something. So it happens less frequently, and it usually happens in some weird edge cases. So
can I see the change in the code you made by any chance?
Yeah. This one.
Are you sharing your
we're seeing a terminal. We're seeing like a terminal.
This is the patch. The patch is showing in the terminal with the changes.
Oh, okay. So which line?
Did you want to see the new code all integrated, or just the changed lines?
I don't mind. I mean, actually, this is fine. But so right now, the way I see it, there's an added line on 755, like a change to the warning.
Oh yeah, sorry, you're right. I was only looking at the here. Let me just do this. I'll show all the changes from main, which includes others. I was trying to isolate it a little bit. So here we go.
No worries.
Great.
Okay, so That was within pre-episode. So
This is
yeah,
all, I think, yeah.
pre-episode. So you'd want it to be within the next call, I think, if queued action is not none, rather than pre. Oh no,
So if queued action. So let
yeah,
me pull this up. So execute jump attempt, right, is in the next.
yeah.
But then at the beginning of execute jump attempt is
Oh,
the,
this is where you're doing it. Okay.
yeah.
So I guess I don't think I don't think execute jump attempt will be executing again on the next step.
Okay.
So I think what you want to do is take that out and
I'd
put
have to
it.
set like.
You could literally put it before
like
this.
way up here.
Exactly.
Right,
if you put it there,
yeah, of course.
then I think you'll catch it. Yeah.
Yeah, there was something, right? There was something about, yeah, the driving goal state is probably set to none, right?
Exactly. Yeah. So
Yeah.
I think the way is that once that's been attempted, it kind of releases that or kind of resets it. So
Okay. So yeah, so then hopefully the warnings will be back to back in the same steps. This won't take too long. Actually, I think I can pause it here. Oh, that almost happened too fast. Wait, let's see. Wait, let's see. Because we want it to be in the next step, but now it's happening. Returning to previous position. It's happening like there's no step change between those two lines.
So that's probably just something about the step counter or something, would be my guess.
Okay.
It probably is the next step, but somehow the step counter is not being iterated, or I don't know. Yeah.
Okay.
All right. But
well,
I think that's a good idea
for.
I think, like Viviane says, distant agent is probably a good place to start, just because it's a bit simpler. And then, but I think this is a nice idea for testing with, the basically passing the off object between these goal state things, which is what we eventually want to do. The other thing is like parallel to this, but probably won't happen anytime soon. We are kind of disentangling this so that you actually have like a full loop, so that if we are going to have this kind of resetting, for example, like you've done here, it would happen on the next step. But yeah, I may have to run soon, unfortunately. But yeah. But was there any kind of other?
Yeah.
I mean, we can definitely do a lot asynchronously as well. Like, obviously feel free to post loads of questions and or point out things that are doing weird stuff.
Great. Yeah. There's questions about how the learning module knows if it's in a learning state, because you said not to use this effect if it's learning.
Yeah.
So I guess I'll just give like previews of things if there's not time to answer them. I can figure that out.
Might be something, just like briefly on that one. So we kind of have a buffer that you save, and then when you are learning, at the end of kind of learning, you update the model. But so that might just be a case of like anything that has this null morphological feature doesn't get added
filtering
to that buffer, or we filter it later at the point of kind of updating the model, something like that.
Yeah, Niels, if you want, I can stay on and answer most of these questions.
Would that be okay?
Yeah.
Okay, cool. Or yeah, just as much as you have time for, and then
yeah,
and then but also happy to.
But yeah, just to know whether it's in learning or inference state, there should be a flag for the learning module as well that tells it whether it should update its models or not. Let me just quickly look up the name of it. Models.
I had in my head that it was like agnostic to the idea of being in a learning state or not.
Yeah,
I guess from an experimental point of view, there is some kind of.
yeah, so from an experimental point of view, it is. Let me share my screen again real quick.
Yeah.
So most of it is, yeah, pretty much.
I'll see you guys later. But yeah,
Yeah,
really nice
All right.
meeting you,
Thanks, man.
Carver. And
Yeah, nice to meet you.
yeah, I'm sure we'll touch base again soon.
Sounds good.
yeah, see you later, Niels. Um, where's our normal learning module code? Here we go. So let me just say, uh, uh, add graph to memory. That should be it. Not
Mhm.
here. That's no, this is just
It wasn't the, let's see. No.
maybe build graph is the right place to start. Build model. Um, mhm. Sorry, it's a bit of a mess. Update memory. Almost there. Here we go. Uh, in the post episode function of learning module. So there's no difference during matching, inference, anything like that. But in the post episode call, we check if the mode of the learning module is train, and we have more than one observation or more than 0 observations in the buffer. Then we call self.update memory. And so basically the only difference between training and evaluation is whether we call self.update memory at the end of an episode. And then if you go deep into the update memory class, as I just went out of,
Right.
you should at some point get to the place where the graph is being built. So yeah, somewhere here, like get infos for graph updates, and that then calls get all locations on object. And that's one of the buffer functions that then, yeah, basically looks at the which IDs in the location array are actually on object and returns those.
Okay. So maybe that also will work already. It just needs to be verified because it's already
Yeah,
doing the filter. Yeah.
yeah. Hopefully, maybe, hopefully.
Right. Okay, cool. Um, so there's the feature change filter and questions about what to do when you go off object for that and whether you pass that in or not. So the feature change filter is on the sensor module side, right?
Yeah,
So I mean, I guess my intuition is the features changed a lot if you moved off the object, but that's not based on anything other than my intuition. So do we then send the data if you move off object or not? And I guess you don't
yeah,
have any access to the model at that point. This is model free, right?
yeah. So we check the feature change in the sensor module, and then if there was a significant feature change, we set use state to true. And I don't think we want to change anything about that. So we still don't want to send observations up if there was no feature change. And uh, yeah, if there's feature change, we want to send it. Let me just check if we're actually looking at off object here. Uh, I think if we put it into the delta thresholds, we actually. Oh, here's a thing. If we're not on the object, then it will automatically say false here, which is probably something that needs to be changed because otherwise, well, either you would have to run all of the experiments without the feature change filter, or otherwise the feature change filter will just filter out all these observations, even if you set it to true in the other part of the code.
Okay, and that's a filter that's on a lot of it's like a default or modern filter, like a lot of
Yeah, it's kind of a
sensors have it.
default. Yeah.
Okay. Okay.
Um, and
And so
so
it makes sense to say, oh, this is a feature or to like run it through the normal data pipeline if it's off object.
yeah, so one thing you could do for first kind of testing is just set it to true here. That's the
Sure.
most basic
Right.
thing. But then
Right.
I think the nicer solution would be to do the same thing we do here and see
Yeah.
if the last feature was on object, then the current one is off, return true. If if basically if last and current are different, then you return true and
Yeah.
otherwise false. So if you're just moving an empty space a bunch, you're not sending all of these. You're really just sending when you move off when you move back on.
Perfect. Um, okay. And then there was undo last action. So so it was called fix me undo last action in the motor policies. To me, it kind of looks like maybe this doesn't need to change because I think it's saying in the step we're in right now, change the thing we did in the previous step, which I think is what we want. That's fine. That is what we want to do, right?
Yeah,
We went off before and now we want to go back on object, and that seems totally fine as a
yeah, yeah, and I think yeah, so I agree. I think we can leave this how it is. And then, yeah, that's also one of the reasons using the distant agent with this kind of policy might be an easier way to debug because this case happens a lot more often where we turn the camera off too far off the object, and then the next step it gets reversed.
okay. Right. Okay. Yeah, I guess I wanted to double check that I understood that right, that it's not somehow doing that all within the same step.
Yeah, no, it I don't think so. I'm just thinking through it again. So we'll call this if the current observation is not on the object. Um, it might be doing it in one step now. Uh, no, yeah, it should send this to the learning module first and then undo the last action. But yeah, maybe something to keep in mind to double check. I'm not sure right now, 100%.
Sounds good. And then the other things were kind of like I didn't even really know enough to know what to ask exactly, except to like help me see and understand where the evidence is applied to a hypothesis. I probably could figure that out, but I think it would help to just like help me find
Yeah,
it in the
for
code.
sure. Yeah, let me go there. So if you go into models and in evidence matching, you'll find the hypothesis updater.
Yeah, it's named in a way that, and now I'm embarrassed that I asked.
Oh no, no, no. It's we're not there yet. So This is just the first part of how to get there. So there's a function called update hypotheses, and that function calls displace hypotheses and compute evidence, which is a function of the hypothesis displacer. It's a file right above it here. And so if you go to that function, that's really the one that does all the heavy lifting. And yeah, I think we should probably split it into two functions since having an and inside of a function name is not a good sign.
It's a pretty good cue, yeah.
Yeah. But anyways, it does exactly those two things. It takes the current hypotheses and rotates, or it takes the current amount that we moved, and the direction we moved, and rotates it by the pose hypotheses. And then it takes the current hypothesis locations and adds those rotated displacements to all of them. And this is where we like update all the hypotheses in parallel. So those are like two big matrix operations to update all of them at the same time. And so then we have an array of search locations in the model's reference frame. We kind of filter them with the evidence update threshold right now for computational efficiency, so we don't test all of them. But yeah, basically the next step is then to calculate the evidence for each of these locations, and that happens in this function. And for that, we also rotate the kind of pose-dependent features by the pose hypotheses first, and then we search for the nearest neighbors in the model's reference frame. So this is the kind of most expensive operation in Monty, I think. It basically takes all these search locations of where we might be on the object, and then for each location, it looks in the object model which points in the model are nearby that location. Does that make sense?
Yeah, I think so. So for this off-object observation, well, that'll just be a special case, I guess. Because at first I was thinking, oh, it's a distant wall, or maybe it won't be. Well, no, it won't really be a special, because we'll still have the location, right? So
Yeah.
we'll still be searching for the right.
Yeah, so what we
We're in a particular location in the hypothesis, but we're looking for those previously saved points that are somewhere nearby that location in the hypothesis, right?
Yeah, so we basically here the black dots are the model. So we saved a bunch of points of where this object exists in our model. And then we have a bunch of hypotheses in the beginning, like we could be on any of these locations on the object in like two possible orientations. And then the sensor moved, so we apply that movement to each of those gray hypotheses. So then we get a bunch of possible locations after the movement, which are the gray dots here. And then maybe the next picture is useful. So this is just the example of one hypothesis. We could be at this location and the cylinder might either be upside down or right side up, the two possible orientations. And then we move like that. So we apply that movement in this direction and in this direction. So there are two possible locations we could be at. And for each of these possible, they're called the search locations in the code. That's what was the output of that call before and what we pass in here. And so for each of these locations, we basically then search in a radius for the points, the nearest points in that radius in the model. So here we have these 3 points now. And then for the 3 points in that radius, we would calculate one, the physical distance between the search location and these points, and the feature difference and pose difference. So do those points actually store the same orientation and the same color and whatever other features you have? And then those get added up, and the best match gets identified. So whichever one is closest and has the best kind of feature match. And however close and well it matches determines how much evidence is being added to this hypothesis.
So this is a place where the distant and surface sensors are going to be really different, right? So the distance sensor is going to give us a location like really far off of our model, probably when it moves off object, right? Like it'll be the location that the distance sensor gives us will be like the horizon, right?
Yeah. Um,
So that'll be like very clearly the search radius will just give us nothing. So that'll
exactly.
be
So yeah, it will basically be, can I draw on this? Uh, so yeah, if we moved off the object from here, it would be like that. Oh, yellow is maybe the worst color to draw in. Uh, it would be like this, and then this would be the search location. There's a radius around it. There's nothing in the radius. So what would happen right now is it gets a penalty of -1
mhm.
for this hypothesis. Um, I don't think it
I
would
guess
be
what I'm saying
different.
is that won't the depth be like the with the distance sensor, the depth of that point will be probably far away, right?
Yeah,
So the
but
translation won't just be perpendicular to you, it'll also be like away from you.
yeah, you mean it would go like all the way back here somewhere.
Yeah, off in the
Yeah,
distance.
right. Although also for the surface agent, you might see a similar thing. Like if the surface agent, I mean, it has like kind of maximum depth it can see, which is not very far. It would just be that
Mhm.
maximum depth that it gets. So yeah, it couldn't be like super out back in the distance, but it would still be,
Right.
usually it would still be off the object and you would still not get any morphological features.
Right. Yeah, right. I guess what I'm so, but the location sent with the surface sensor and the null morphology could be right next to the surface, right? You can move just off of that
Yeah,
cylinder. And
right.
so
That's true, yeah.
like you're playing a game with like, is the search radius bigger, is big enough, will the search radius catch the edge
Yeah,
of this object, even though, it's not supposed to be, even though you
right.
really are off of it. Yeah.
Yeah, yeah, that's a good point. Yeah, for the surface agent, it would just be yeah, it could be a pretty small location change. And then yeah, there might still be a point in the search radius, even though we're
Right.
not getting morphological features.
Yeah. And we don't want to give it a heavy penalty for that because
Um,
it sort of looks like, oh, there
yeah,
should be a point there, but there's not, which in these other examples should be heavily penalized, but here seems like, oh,
right.
it shouldn't.
Yeah, that's kind of the what I think Niels called the edge case.
Okay, right.
Because yeah, we're not sure yet how much of a negative effect this will have um, on performance. Because yeah, like you say, you wouldn't really want to penalize it just because the search radius is so large that it still picks this up. Um,
The other thing, I mean, I guess if you want to get sort of fancy, the surface normal could tell you some information about how bad it is that you're off object, but expect to be on it. Like if the surface normal is pointing at, I don't know, away from the sense object, from the null
yeah, that's
observation,
actually
like
we have something a little bit like that, and yeah,
okay,
I've been meaning to like try and think about if we can improve this more. But yeah, basically when we do the search radius of the nearest neighbors, it's usually not a perfect circle like this, but instead it's like a squashed sphere that goes
okay,
along the like perpendicular to the surface normal. So if the surface normal is
okay.
like this, then the search radius would be kind of perpendicular to it, so a kind of a sphere around the surface. And
But that's the surface normal that you've sensed, right? And
yeah,
our off object won't have any surface normal. We only get the surface normals for the actual hypotheses, right?
right. Yeah, so I guess one possible solution could be that if there's no morphological feature, so no surface normal, the search radius becomes very small.
Hmm.
Well, would that work? Hmm, maybe it wouldn't. Maybe that would solve the edge case, but ruin all the other cases. Uh,
Once things get noisy,
yeah,
yeah, I can imagine it being a problem.
yeah. Um, yeah. So I guess right now the idea would be to just kind of see how big of an effect that would have. And then
Yeah.
if it is an issue, try and think about ways we could solve that. But it might be more of an yeah, edge case, I guess. Uh,
Right.
um, but yeah, does that kind of clarify where the evidence gets updated?
Yes. Yeah, that was excellent.
Okay, I guess yeah,
Um,
I didn't go further. Like yeah, basically just the last step. Once you have the nodes in the search radius, the next lines of the code will do the kind of finding the distance to them and calculating the feature difference between them and then calculating the evidence from that.
okay.
Uh,
Okay.
And yeah,
Great.
this is where uh, no points were found in the search radius.
Okay. Cool. Um, and then I guess the last thing was that I still have kind of a vague idea that we're stepping through the environment and then no, Monty, no, the experiment, and then Monty, and then the environment. This is there's the diagram that I can go look up, but I don't feel like I wanted to be able to see in one place where the whole flow is of like knowing that there's, because sometimes it seems like, for example, like the sensor is allowed to take multiple steps uh within a single like step, like Monty step or something. So because
Yeah.
I saw some code somewhere where inside of the step it like called the next step inside of the sensor, and so I was just trying to figure out like when is that allowed, or I was just trying to wrap my head around the like
Yeah.
flow and even the ordering of things. Like, is it always, so it's always like policy and then, or like
Yeah.
motor and then sensor and then learning module within a single step, or that kind of thing.
Yeah. So maybe this
Sensor and then
more
learning and then
useful.
motor.
So there's a different view of this kind of class diagram, which is really more about how these classes are related to each other. This is more
Right.
the flow of information through things. So I'll start here maybe. So we have the environment, which is in this case habitat that renders the objects, the simulator. And then we have an environment interface around that, which basically controls the simulator. So there we specify things like which object should you initialize in which episode and what orientation should it have, and delete the previous object when the next episode starts, kind of thing. Um, and then that kind of also steps the agent through the environment. And so when it gets an action from the motor system, it steps the environment and it gets a new observation from the environment. And that observation gets sent to the sensor module. And then the sensor module checks, like it extracts features and poses, but it also can do other things like check if there was significant feature change. Um, if there was no significant feature change, for example, then it wouldn't be sent to the learning module. We would skip the stepping the learning module and step the motor system right away, send the next action, go here. But if we're not looking at that, then usually the sensor module output would go to the learning module. The learning module would use those features at locations to update its hypotheses, and then it might output a suggested action to the motor system, and then the motor system translates. So the learning module would output a target location in space, and then the motor system would translate that into like whatever the agent is capable of. If it's a camera that can only tilt, or a touch sensor that can move along the surface, it would kind of translate that to the specific language of that agent and send it to the environment.
Okay. And for like model-free movements, sometimes can the sensor module can like do movements itself, or like send. Can you give one
Yeah,
example where we're skipping over to the model?
yeah. So I think let me see if I have a good diagram of that somewhere. No, yeah, maybe here. This was a result of a brainstorming session, so it's a bit
Okay.
messy. And it's a bit older because then we still had that data load and data set. Now that's the environment interface. But so maybe the
Thanks to
simplified version
Anna, if I
is the.
remember correctly.
Sorry?
So thanks to Anna, if I remember correctly.
Yeah, exactly. Yeah. Very good. So basically, we have three kind of action loops. One is the reflex loop that goes directly from the environment to the motor system, and no kind of further information processing happens. It's kind of if you imagine a safety loop where, like, if you touch something really hot, it goes back. You don't need to do any further processing. Uh, but then the most interesting ones are the model-free and model-based loops. So model 3 is you basically send the sensor module output directly to the motor system, and then the motor system determines what to do. Um, and model based is it goes to the learning module, and then the learning module figures out what to do next and sends a goal to the motor system. And just because you send this and the next action is based on sensor module information, doesn't mean it can't go to the learning module too. So actually, most of the time we do model-free stuff, like we move along the direction of principal curvature or something like that, um, like along the rim of the cup and stuff like that. And that only requires knowing what the sensor is currently sensing. It doesn't need any models. So the motor system is basing its actions on what the sensor module is sensing, but we're still processing and updating hypotheses in the learning module.
Okay.
Yeah, is that
Is could you, yeah, it would even like also can you take me to the code in Monty where it's like
yeah,
passing these things?
yeah, for sure. So the Monty class kind of handles most of these things. Um, so let's see. Um, where to go?
That was interesting. The step, it was like the step is, there were different kinds of step.
Yeah. Uh, yeah, I guess the most high-level overview of the kind of order of things is here in this Monty class. And so basically we in an usual matching step, which is the steps where we actually process stuff in the learning module, we would aggregate sensory input. So basically get the um, uh, whatever raw observations we get from the environment, and then pass that through the sensor modules. Let me just double check if that's true. Um, yeah, so we basically get the observation from the environment, which is the RGPD camera image, and we loop over the sensor modules, uh, get whatever observation is for that sensor module, and step the sensor module to get the processed output, and then append that all into an array, which is then assigned to sensor module outputs in the Monty class.
Interesting.
And
It's also doing the learning module outputs in here too.
yeah, so it's if you think of Monty as like a hierarchy of sensor modules at the lowest level and then learning modules at all the levels. It's not like to process at the highest level of the hierarchy if the high level learning module. It's not like the highest level learning module is only called, like you have to call them in succession of the level of hierarchy they're in, but instead all learning modules get stepped at the same time. And it's just that the highest level one might not get any input for a couple of steps because the input needs to propagate through the hierarchy first. But basically, this part here just looks at what is the current learning module output from the previous step so that it can become the input for the next step. And that's because in Monty there isn't really a clear hierarchy. I mean, learning module output can go to another learning module as input, but it could skip a level in the hierarchy or several levels in the hierarchy. It wouldn't mind. So basically, what we do is collect all the outputs from the sensor modules and learning modules from the previous state that they were in, and then put them as input to all of them at the same time again. Does that make sense?
Gotcha. Yeah, totally.
Okay. So yeah, like you said, we also loop over all the learning modules called get output, and that depends on what state they were in before. At the very first step, that would just be nothing, or even at the first, I don't know, 10 or 20 steps, while the learning module doesn't have a certain hypothesis yet, it won't produce an output. And then yeah, we have these two lists. And then where was the abstract class for the overflow? Then we would step the learning modules. Um, and yeah, that's a bit hard to, yeah, here. So again, we loop over all the learning modules and we extract what inputs should go to that learning module. And then the important part is this one here, or this one. We figure out which type of step we want to do right now. We have matching step and exploratory step, and then we apply that to the sensory inputs where we do learning module.step with sensor inputs. And then the rest is just some logging stuff. That's not that important. And yeah, so we pass the sensor stuff into the learning module step, but that's where all the hypothesis updates happen. Where was the strict class again? And then after that, we vote. So after all the learning modules have updated their hypotheses, we go and check them all again, see like, hey, what's your current vote on what you're sensing, and update them based on that. And then we pass the goals. So then we go back to all the learning modules and say, hey, where do you want to move next? And then each learning module produces a target location in space. Sensor modules can also do that. And then we pass that to the motor system, and the motor system basically resolves, okay, which one am I going to execute? Where am I going to go? And then outputs an action to the environment. And yeah, this is just to check whether an episode should be done or not, like if Monty is confident in what it's sensing.
Right. Yeah, this is great. That's super helpful. So, and then exploratory versus matching is we don't have to. I don't need to step through the exploratory, but just to understand the difference at the high level.
Yeah, it's really not that important. We're basically doing it to save compute. So essentially, after Monty has recognized an object, it wants to learn more about it. So if Monty's in training phase, so it actually is supposed to update its models, it might recognize the mug after just moving a little bit. says, oh yeah, that's the thousand brains mark. Let me update my model with some new points that I just saw. But since these new points were like they were used to recognize it, they're not going to add a lot of extra new information about the object, and there are very few points. So it would be quite slow to learn that way. So what we do is after it's recognized, we explore it a bit more, and eventually, like one of our goals is to have some better exploratory policies, like that basically look at, okay, where is my model kind of underrepresented? Where do I have highest uncertainty? So let's go there and learn a bit more about this part of the mug. We don't do that right now. We just move randomly some more, collect more points. And since we're just exploring, we already recognize the object. We don't really want to like spend every step updating hypotheses again. So that we just clamp that part of the code to not update hypotheses. Eventually, we might want to keep doing that because if we're in an environment with many objects, we might move on to a different object and we want to recognize that again. So it might just be some kind of useful uh, thing we're using for the current setup to save some time. But conceptually, it's not that important. It's not really an important conceptual feature of Monty. It's more of a let me run my experiments a bit faster kind of thing.
Okay, great. Cool. Yeah, this is all super helpful. And yeah, I think that's like covers my list of like questions for now. Um, yeah, yeah, like I said, thank you so much. It was really,
Yeah,
really valuable.
yeah, for sure. Yeah, thank you. I mean, this is it's a pretty steep learning curve, I know. So
Yeah.
definitely cool that you're up for it and uh, diving deep
I
into
liked
it.
it when you said you're like you wrote this down a few years ago, like, oh yeah, this will be just like a quick to-do item to take care of later. And then the more you look into it, like, oh, this will take a little bit. This will take a
Yeah.
little bit of thought.
And
Yeah.
like, yeah. Yeah, it's probably one of the hardest items you could have picked. Or like, I don't know, maybe not. Maybe it turns out it just works, but it feels like we came back to it many times. We always confused ourselves again, and then decided, okay, let's hold off for now. But it would be really cool to have that finally in the code. So
But yeah. Yeah, I didn't even know I was jumping in the deep end, but here I am.
yeah, so yeah, definitely feel free to write anytime you run into questions, and we can also schedule a next meeting. Um, maybe after the holidays, because yeah, I'm taking
Yeah.
some time off too. But yeah, really cool that you're up for this challenge.